Welcome back to part two. We're going to get started with the directions of the parachute. So today, parachutes are used to deploy troops, materials into war zones, deliver supplies and cargo, save lives, slow down aircrafts, and more recently for the sport of skydiving. The simple concept has evolved into a masterful invention that can be steered and manipulated, almost kind of like an airplane, just by using lift, drag, and gravity. So those are some important terms you'll need to know for today's activity. So your challenge is going to be to build a better parachute. When the STEM Explorer bus visits our school, you'll be given an opportunity to test parachutes that you have made with projectile fired from an air cannon. You should build and test your parachutes before the day they are fired in the air cannons and the STEM bus gets here. So that's where we're going to start today. Our class is going to be divided into groups and will be given identical sets of material. You will be provided with 3 plastic grocery bags, 1 container of unwaxed dental floss, 1 sheet of circle stickers, scissors, Q-tips, and a hole punch. Okay? And you're going to design 3 different types of parachutes with these materials. You can use a drogue chute design, a hole cut in the center design, or anything else you can dream up as long as you only use the items provided in this list. You're welcome to research some parachute designs. I'll post some links on the Bitmoji page for you to use, as well as the helpful how-to video I am going to require everybody to watch as well. You are going to You're going to tie dental floss to each hole or tie down spot that you make, making sure that the pieces are about the same length and that there are at least 4 holes per parachute. You're going to cut 3/4 of an inch section of their Q-tips provided in the box. You will need to tie the dental floss strings onto the Q-tip so that they can easily attach to the chute to the mortar in our projectile equipment. And finally, you're going to test your 3 competing designs within your group by launching them, and we will do this outside before, we'll let you know the location of that, depending on weather, before the STEM bus arrives Thursday. We will use stopwatches, and you're going to create kind of a graph of your data and how you can I'll let you have the choice to decide how you are going to represent your data in a meaningful way. The variables are numerous in this experiment. As just one example, think about the height from which the parachute is dropped. It will need to pick up some speed before air resistance opens the chute and slows it down. So it is usually true that the higher the better. I'm thinking probably the fire escape is where we will drop them from. Does the parachute want to rock back and forth? Maybe it needs a hole in the middle to allow the air to flow through it uniformly. Did the larger parachute work better? Larger parachutes take longer to deploy but have more surface area to create more drag. Did you want to make a smaller chute to deploy quickly? The main chute speed up deployment? Did the number of strings have an impact on performance? These are all questions you'll need to ask yourself as you're designing your parachutes with your group. I look forward to seeing what you come up with. And again, this following slide will be what we work on when the STEM bus actually comes to our school. However, you will be given this paper copy of this manual, so you will get to see it then.